In example 2, they gave us a graph. They call it f of x. First thing, if you do have a red pen, I would like you to draw a dotted line at y equals 0, and another dotted line, which these are the asymptotes at x equals 0. And the first thing that is important sort of as a preliminary before you jump into sketching the new graph, we are going to make sure that the new equation is in all the forms that we like. First of all, I like the y by itself. So the fact that it has y plus 4, I'm going to move that 4 over to the other side. Second, I'm going to notice that this is already in factored form. And I also want you to notice something I did when I wrote it. You notice I have some brackets that are bigger than other brackets? That is a really nice visual for yourself to see that, oh, the big bracket goes with the other big bracket, and the little bracket goes with the little bracket. It helps you visualize it a little bit better. So I noticed this one's already in factored form. And I'm going to start listing all the transformations that I see. Yes?
So if they give us a graph and the equation isn't in factored form, they will have to...
Yeah, that'll be part of the preliminary. Before I would even start, I would say, I need to make my equation in the form where I can recognize things. So this is in factored form. Now I can start recognizing things. This is inside the brackets. It's horizontal. That half is a stretch, right? X's are liars. We're going to multiply x by 2. And the plus 1 is inside. That's a horizontal translation. And x's are liars. We are going to go left 1 unit. And then the minus 4 is outside. That's going to tell us we're going to go 4 down. I'm going to use the points that they gave us. I'm a little disappointed. That's okay. Why am I disappointed? I really want to use the, like, if you were doing this question on your own, you see those big red dots that I made? That one is at 1, 1 and -1, -1. Those are nicer points to use. So if you were doing this on your own, those would be the points that I would suggest using. However, these were the points they gave me, so I'll be nice. I'll use the points the textbook gave me. And we draw an arrow. We'll do our stretches and compressions first, then our translations second. So do we have any stretches? Just the one. We need to multiply our x values by 2. So this will be 4, and this will be -4. So y values of 0.5 won't change. And then for translations, we're going left 1 unit and 4 down. So if I go left, that'll be at 3 and -5. And 4 down, this will be at -3.5 and -4.5. The other thing that we want to find out is what's going to happen to our two asymptotes. Let me get a little note there that our asymptotes are only going to be affected by translations because they started at 0. Does it make, like we have x by 2. You could go to your x1, which is at 0, and multiply it by 2. What's 0 times 2? 0. So if you have asymptotes at 0, they are not going to be affected by multiplying. They will only be affected by translations. And so we have to think about the y equals 0, the horizontal one. If you have a horizontal line that goes on forever, and you move it left and right, can you see that it would still be exactly at the same place if it went forever on that horizontal line? The only thing that's going to affect y equals 0 is if you move it up or down. And so we're going to get, since we moved down, that one's going to change to y equals -4. Same thing with your vertical one at x equals 0. If you move a vertical line that goes on forever up and down, it will still be exactly in the same spot. But if we move our vertical line 1 to the left, we are going to get x to the -1.
I noticed if you just like average the two different, like you average the 3 and the -5 to get what the asymptote is.
Yes.
Is that always going to be the case, or is that just?
It will be for, I mean, we chose points that were symmetrical to begin with.
So it would have to be like an A and A prime.
Yeah, like it'd have to be 2 points, like if you chose 1 and 1 and -1 and 1, since they're already the same distances away, the averages would work. But had you chose 1 point as 2, 0.5, and the other one is -1, -1, then it wouldn't work that way. It's just as easy, I think, to just take them and move them left, right, up, and down. But it is a good observation because of the symmetry here that it happens to be perfectly in between the points that we have. Now for this one, we're going to sketch a separate graph for this. I find the graphs with asymptotes, if you try to put 2 of them on the same graph, it just gets really busy and hard to see what's happened. So I'm going to, on a separate graph, go 1, 2, 3, 4, 5 in each direction here. And I have an asymptote at x equals -1, an asymptote at y equals 4, and I have 3, -3.5, and I have -5, -4.5, and with the asymptotes, and just those 2 points is enough to draw the graph. I'm going to add a part B to this question. Did you recognize the original graph there was one, from our blue sheet, the 1 over x graph. Okay? So now we want to write the explicit equation for the green one. Now, when the green one was written to us originally, it had f of 1/2 x plus 1 minus 4. This was not an explicit equation because it has the function f. It is very useful to know how to move from function notation to actual notation. And once you see it, it becomes super easy. But sometimes seeing it for that first time takes a long time, or it's a little bit tricky. Okay? Here is the idea. Here is my original function. F of x is 1 over x. Where you know from functions, whatever you put in, like if I asked you, what's f of 3? You would have probably no problem telling me it's 1/3. Because if I ask you f of 3, you would say, oh, I replaced the x with a 3. That's pretty straightforward. And in fact, I could probably tell you any number and you'd be fine. What's f of 7? You'd be like 1/7. I'm like, ooh, what if I do a negative? What's f of negative 6? You'd be like 1 over negative 6. Perfect. But as soon as we start putting in variables inside, it gets a little bit trickier. So now I'm going to take up my highlighter and I'm going to say, notice here, all of this is now inside of f. So if I want to change this from function notation to its explicit equation, it will look like this. Well, what's the rule for f of x in red? Whatever you put in goes in the bottom of the fraction. So I would have 1 over, and on the bottom of my fraction, what was in the yellow, notice it gets replaced where the x was. And then I have a minus 4 after. That minus 4 after would be the same. Okay? This is the explicit equation. And the question is, I could give you this question and say, graph it and give it to you in this form. Then you would have to recognize that this is a 1 over x graph with things that have been changed. And whatever's in the yellow box, those are all my horizontal transformations. And the minus 4 is outside of the function, so that would be vertical. All right. Questions sponsored by 7-Eleven. I think they should give me a free Slurpee for that advertisement.